Okay, let's cut right to it. Quantum computing, right?
Hmm.
For years, it felt like, I don't know, this sci-fi thing always just over the horizon.
Always 10 years away, yeah.
Exactly. Stuck in a lab somewhere. Fascinating, sure, but kind of theoretical.
Mm-hmm.
Well, that picture, it just shifted big time. We're talking a real moment of quantum supremacy, and not just raw power, but like useful power.
And right at the center of this, you've got D-Wave, the Canadian company.
That's the one.
So today, we're really going to dive into their big announcement. We're drawing a lot from this piece. D-Wave, quantum supremacy just got real.
And look, this isn't just another small step. It feels more like a major statement.
Totally. It's like D-Wave just planted this massive flag in the ground. It really signals something new for quantum tech. And by the end of this deep dive, you'll get why this isn't just, news for physicists.
Right.
It matters for industry, for innovation, and ultimately for you. So let's get into it, this quantum tipping point. What exactly happened here?
Okay, so D-Wave has this new machine, the Advantage 2 prototype.
Right. And they gave it this incredibly tough job simulating quantum magnetic materials, specifically something called spin glass dynamics.
Okay, spin glass dynamics. For listeners, maybe not deep in condensed matter physics, what does that actually mean? Can you break that down a bit?
Sure, yeah. Think of it like trying to predict how a whole bunch of tiny, tiny magnets behave when they're all jumbled up in a messy material.
Okay.
Each magnet wants to point a certain way, but it's constantly getting nudged and pulled by its neighbors in this really complex, almost chaotic dance. Simulating that is super important because it's actually a model for lots of other really hard optimization problems.
Problems we see everywhere.
Exactly. Material science, drug discovery, logistics. All sorts of complex systems have parallels to this.
And that's the kicker, right? Because simulating this isn't just hard, it's practically impossible for even our best classical supercomputers.
Oh, absolutely. Get this. Oak Ridge National Lab's Frontier computer, currently the world's fastest.
Yeah.
It would need, estimates say, over 1 million years to run the simulation properly.
1 million years.
1 million years. Now, D-Wave's machine did the exact same task in minutes.
Wow. Just minutes.
Minutes, not hours, not days, minutes. We're talking orders and orders of magnitude faster.
Yeah.
But here's the other crazy part.
Go on.
The energy it used, a tiny fraction of what Frontier would need. It's like comparing a city's power grid to maybe a single light bulb. The efficiency is just freakishly good.
1 million years versus minutes using almost no power. That's not just Moore's Law ticking along. That's something else entirely.
It really redefines the boundary, doesn't it?
It absolutely does. That's a completely new benchmark.
And when you look back at D-Wave's whole story, it makes this even more interesting. They started way back, 1999.
Ancient history in tech terms.
Pretty much. And right from the start, they were focused on this thing called quantum annealing.
Which was different from what everyone else was doing.
Yeah, most of the big players, the Googles, the IBMs, they were chasing gate model quantum computing, trying to build a universal, programmable quantum machine.
Like a quantum version of my laptop, eventually.
Kind of, yeah. But D-Wave, they went for optimization problems, finding the lowest energy state in a super complex system. The analogy they often use is like dropping a ball onto a crazy mountain range and just letting it roll down naturally to find the absolute lowest valley.
Okay, I get that. More specialized.
Exactly. And their focus early on was always practical stuff, real-world headaches like supply chains or traffic routing or simulating physical systems like these magnets.
But they got a lot of flack for it, didn't they? I remember for years people were kind of dismissive.
Oh, definitely. Brushed off by a lot of the, let's say, quantum establishment.
Like, that's not really quantum, or it's not actually useful.
All that, yeah. But D-Wave just kept plugging away, iterating on their hardware. They went from their first machine, the D-Wave one, which had, 128 qubits?
Tiny by today's standards.
Right. And now they're at this Advantage 2 prototype, over 4,400 qubits. And it uses this Zephyr topology. Can you maybe explain why that topology is important?
Sure. The Zephyr topology is basically their unique chip layout. The key thing is how it connects the qubits.
Okay.
It gives each qubit really good connectivity, basically. Each one can directly talk to or interact with 20 other qubits.
20 neighbors. That sounds like a lot.
It is. And that high level of connection is super important for mapping these complex optimization problems onto the chip efficiently. It lets them tackle bigger, harder problems more directly.
So all those years of people doubting them.
Well, that sound you might be hearing could be some critics eating a bit of humble pie.
Yeah, maybe just a little.
And look, science demands scrutiny, right? That's healthy.
Of course.
This D-Wave result, it was published in Science back in March 2025. Peer-reviewed.
Right, the gold standard. But yeah, some researchers from places like Flatiron Institute, EPFL, they did come back and say, well, hang on, maybe some classical algorithms could do okay on some specific, maybe simpler versions of this problem.
Okay, so here's back.
Which is normal. D-Wave's response was basically, look, those were kind of cherry-picked cases. We compared against the best supercomputers on the full hard problem. This whole back and forth, it's how science moves forward and makes the claim stronger in the end.
So the bottom line is D-Wave's claim holds up.
It seems robust, yeah. It's backed by comparisons to real supercomputers, running real code, getting real data.
Okay, so beyond the numbers, beyond the compute power, here's where it gets really interesting for everyone listening. Simulating magnetic materials. Sounds academic.
But it's not. It's fundamental for so many things. New sensors, better superconductors.
MRIs in hospitals.
Exactly. Better medical imaging. Spintronics, which could lead to new types of electronics. Understanding these materials better lets us design new ones much, much faster than before.
And this annealing approach, it works for other stuff too, right? You mentioned optimization.
Oh yeah, the potential applications are broad. Think about finance.
Okay.
Optimizing huge investment portfolios, figuring out risk models in real time, spotting arbitrage opportunities faster than anyone else.
Makes sense. What else?
Logistics. Imagine optimizing the routes for every delivery truck in a massive fleet, or figuring out the absolute best way to arrange products in a giant warehouse.
Saving time, saving fuel, saving money.
Precisely. Managing inventory across complex supply chains. Then there's healthcare.
Drug discovery.
Big time. Modeling how molecules interact to find new drug candidates way faster. And energy predicting demand on the power grid, integrating renewables smoothly.
Wow.
We're even seeing potential in things like quantum-powered blockchain. It really touches a lot of areas.
And the key thing here, which I find fascinating, is D-Wave isn't just talking about this stuff in a lab. They're actually selling these machines.
Right. They have actual customers.
Like the Jülich Supercomputing Center in Germany. They bought one, didn't they?
They did for, was it $12.6 million?
$12.6 million. You don't spend that kind of money on a science experiment unless you're pretty darn sure it's going to deliver something critical.
It's a huge vote of confidence, and it shows up in their financials, too.
Yeah, tell us about that, because D-Wave stock for a long time was kind of, well, a bit of a meme stock almost.
Yeah.
Speculative.
Very much so. But then this quantum supremacy claim hits, and you look at their Q1 numbers for 2025. Bam! Revenue up 509% compared to the year before.
509%.
Yeah. $15 million in revenue just in that quarter, mostly from selling these systems. And their net loss, it shrank dramatically. Went from like $17.3 million down to $5.4 million.
Getting closer to profitability.
Definitely heading that way. And the stock price jumped over 25% pretty quickly after the news.
So suddenly, D-Wave isn't just this quirky science project anymore.
Nope. It's a business. And looking like potentially a very good one.
Which brings us to this philosophical war you hear about in quantum computing.
Yeah, it's a good way to put it.
You've got the gate-based systems on one side, IBM, Google, IonQ.
Right. The ones aiming for that universal, fully programmable quantum computer. Theoretically, they could do anything.
What you catch is?
The catch is right now, they're generally slow, they make a lot of errors that need correcting, and scaling them up to be truly useful is still proving really, really hard. We're talking years away, maybe longer, for many practical uses.
Okay, so that's one camp. Then you've got D-Wave's approach.
Quantum annealing. It's different, it's specialized, it's built for those optimization problems we talked about.
Not universal.
Not universal, but,
Right.
And this is the crucial point, it is scalable, and it is commercially viable today. Right now.
So it's like D-Wave didn't wait around trying to build the perfect all-purpose machine for the theoretical Olympics.
Ah, I like that.
They built a really fast bobsled for a specific race they knew they could win now. Like, cool runnings, let's go.
That's a pretty good analogy, actually. They focused on delivering value on specific, hard problems that businesses face today.
Well, IBM and others are promising amazing things in, say, 2035.
D-Wave is shipping hardware and solving problems in 2025. It's just a different strategy. And right now, their strategy looks like it's paying off. So where does D-Wave go from here? This isn't the end of the story, obviously.
Right, it feels like just the beginning.
Definitely. Expect to see more studies, more peer review, testing their systems on even wider, tougher problems.
More validation.
Exactly. Commercially, expect them to push hard on selling more Advantage 2 systems globally, getting them into more research labs, more companies.
And what about access for people who can't spend $12 million?
That's where their cloud platform, Leap, comes in. They'll likely keep expanding cloud access so developers anywhere can experiment and build applications.
Makes sense.
We'll also see more focus on hybrid models, figuring out the smartest ways to combine D-Wave's quantum power with classical computers.
Right.
Some problems might need both working together.
The best of both worlds.
Kind of, yeah. And finally, just growing the whole ecosystem. Better software tools, better APIs, more partnerships to make it easier for people to actually use this quantum power.
Okay, so let's bring this right back to the listener. What does all this mean for you sitting there listening, maybe not working directly in quantum physics or high finance?
Right. Why should you care?
Yeah. Because this isn't just about scientists and labs doing, quantum stuff in quantum caves.
Absolutely not. Think about it. Faster breakthroughs in material science. That means potentially better batteries for your phone, your car, new kinds of medicines developed faster, stronger, maybe more efficient semiconductors for all our electronics.
Okay, tangible benefits.
Optimized supply chains. That could mean cheaper products on the shelves, faster delivery times for things you order online.
Yeah, hits home.
Smarter AI. If quantum can help train AI models faster or better, that accelerates innovation across the board. Personalized medicine, climate modeling, renewable energy optimization. It feeds into so many areas that will eventually touch your life.
So the ripple effect is potentially huge.
It really is. This is about real-world transformation, driven by a new kind of computation.
So D-Wave,
Yeah.
the company many people kind of wrote off the underdog,
Yep.
they just showed up and delivered actual practical quantum supremacy. Pretty impressive. Did it with style, speed, and maybe a bit of that cold Canadian swagger.
Quantum supremacy just got real. And, for everyone else still chasing the theoretical dream, maybe the clock's ticking a bit louder now.
A wake-up call?
Could be. Better start annealing, or maybe risk getting left behind.
Wow. Something to think about. How quickly that future, the one that always seemed 10 years away, can suddenly just arrive and change the whole game.